And now it is your turn to simplify some radical expressions, some involving addition, and some involving multiplication, and some involving both. Please pause the video to return to your lecture notes to attempt these 3 parts on your own first, and then return back to the video to check your work. In part A, we need to simplify root 5 plus root 45. To be able to simplify radical terms, they must have like radical factors. 5 and 45 are not the same, so root 5 and root 45 are not like. But 45 does have a perfect square factor in it, so I could rewrite root 5 plus root 45 as root 5 plus root 9 times 5. The reason for doing this, 9 is a perfect square, so root 5 plus root 9 times 5 becomes root 5 plus root 9 times root 5. Again, the reason for doing this, the square root of 9 will simplify to be 3. So root 5 plus root 9 times root 5 can be rewritten as root 5 plus 3 root 5. And now that they are both root 5 terms, we can add them. 1 root 5 plus 3 root 5 is 4 root 5. In part B, we need to multiply 2 root 5 times 3 root 20. It is important to recognize that the coefficients will be multiplied together separately from the radicals. So we'll really end up with 2 times 3 times root 5 times root 20. In the front, 2 times 3, the coefficients, 2 times 3 is 6. In the back, 2 square roots being multiplied together can be rewritten as 1 square root with both factors under the radical. So root 5 times root 20 is root 5 times 20. Well, looking under that radical, 5 times 20 is 100, so we could rewrite this as 6 root 100. Well, we know the square root of 100 is 10, so this could become 6 times 10. And hopefully we're familiar, 6 times 10 is 60. So sometimes things that start out with messy radicals might clean up to be very nice integers. In part C, we need to multiply root 3 plus 5, in parentheses, times root 2 minus root 7, and then simplify the result we get from that. To multiply these two together, we need to recognize that we're going to have foiling occurring. We have 2 things in parentheses, each with addition or subtraction inside the parentheses, and multiplication between the parentheses. So we need to follow our standard first, outer, inner, last combination. So for the first terms, root 3 times root 2, 3 times 2 is 6, so root 3 times root 2 is root 6. For the outer terms, or the outside terms, root 3 times a negative root 7. 3 times 7 is 21. A positive times a negative is negative, so we will end up with negative root 21. On the inside or inner terms, 5 times the square root of 2. Well, 5 is a whole number, and the 2 is under the radical. They're not going to interact, so we simply end up with plus 5 root 2. And for the last terms, 5 times the negative square root of 7. Again, a positive times a negative will be negative. 5's outside the radical, 7's under the radical, so they're not going to interact, and we'll end up with negative 5 root 7. So at this point, we have now expanded that original expression into root 6 minus root 21 plus 5 root 2 minus 5 root 7. The next task that we were asked to do was to simplify. Well, to do that, we would need to find a radical that could simplify. But looking at each of those radicals one at a time, the square root of 6, there is no perfect square that divides evenly into 6, so we cannot simplify that. Square root of 21, same thing, there is no perfect square that divides evenly into 21, so root 21 will not simplify. Root 2 and root 7 are in the same boat. There is no perfect square that divides into 2 or 7 that will help us simplify this, and so they are what they are. Since none of those radicals will simplify, and none of the radicals are identical, there is no simplification that we can do here. So the final answer is root 6 minus root 21 plus 5 root 2 minus 5 root 7.